So before we go into the main part of the session, I'll just give a little bit of background about Maths Mastery. It's part of the ARC Curriculum Plus partnership, and it was grown out of ARC, which is one of the highest performing multi-academy trusts in the UK. And our programmes, which include Maths Mastery Secondary, Maths Mastery Primary, English Mastery, Science Mastery, and other primary programmes are now being used by 600 schools and 15 maths in England. And our mission is to empower teachers to give every young person, regardless of their background, subject knowledge and skills that will allow them to succeed. Children and young people are at the centre of what we do. And our team of research-informed curriculum designers and expert trainers are former or current teachers who, like you, want to ensure success in maths for all Key Stage 3 students, regardless of their starting places. And our curriculum is heavily influenced by research for cognitive science and how it can be deployed in the classroom to drive student attainment. So I was a former teacher, I still like to think I am a teacher, and I worked for a very long time in the classroom, then as head of maths, and then as assistant head teacher before I came to Maths Mastery. So in our last webinar, I made this bold statement. I said Maths Mastery is both a curriculum and PD programme that supports teachers in developing their subject knowledge and pedagogical expertise through each and every engagement with the programme. I felt that it was a bit of a bold claim when I was writing it, but in the webinar, I went through and exemplified every aspect of that claim. So if you'd like a copy of that to see how we develop teachers' subject knowledge and pedagogical expertise, do just let Sophie know and she'll be able to share the recording of that webinar with you. But in this webinar, we're going to be looking at how we align with best practice advocated by the Educational Endowment Foundation, particularly their guidance report for Key Stage 2 and Key Stage 3 maths, and the relatively new NCETM DFE guidance for Key Stage 3, a whopping 295-page document. So I won't be judging any of you if you haven't read it from back to front, but I've been through it with a fine-tooth comb, and I'm going to share how our programme aligns with many of the elements in that document. And I'm going to pause every so often in case there's anything in the chat that Sophie needs to address.
No, not at the moment. That's absolutely fine. Yes, I can share the previous recording of the last webinar with you. I'll send out after this webinar's finished.
Thank you. Okay, so as I said, I do have a bit of a dream job because I spend all my time watching maths teachers teaching maths and talking to students about the maths they're learning. Very recently, I was in a classroom where a group of low priority retaining students were just beginning to learn about factorising. They're meeting it for the first time. And the students that I was with didn't have access to manipulatives, but the teacher was doing a really good job in demonstrating using virtual manipulatives on the boards. And what I noticed as I listened to the students, well, I'm also an extra pair of eyes and ears in the classroom as well, and see things that the teacher doesn't always get to see, is that students in this classroom could see the fiveness of this problem. They knew it had something to do with 5. And they were looking, they had some multi-linked cubes and Dean's blocks that virtually on the board and were being asked to group them. And their sense was that they should be grouped like this because of that fiveness. So the blue multi-link cube represents the A's and the Dean's ones represents the constant ones. So that's how they suggested the teacher group them in this start of beginning to factorise. And the teacher demonstrated the problem of grouping them like that because we'd end up with that. So he asked the students what should he do, and one student, bless them, said, oh, I think possibly you could just throw away those other 2 blue cubes because they're extra. So you can see that there's a problem there in thinking about 5A plus 15 in this quite abstract way. Even with the multi-link cubes which were on the board, it was still a little bit difficult for these students. So it's difficult. It's difficult to use manipulatives in the classroom. I know that from my own experience, and I imagine that you probably know that too. And I'd love to know, if you don't mind popping into the chat, what it is that's difficult about using manipulatives. So whether it's multi-link cubes or deans or counters, what is it that makes them difficult to use in the classroom in your experience? I'm just going to have a quick look at the chat. I would love you to contribute to that. So I don't, while you're typing, and you can never see if anyone's typing when they're on Zoom, I don't want to preempt anyone's, but I know that certainly I've had the experience of students just simply love to make guns out of multi-link cubes, and then possibly
that's literally what someone was saying.
play with them instead of doing the thing that they're supposed to do with them. And so someone else is saying they only have access to online resources and not those concrete manipulatives. And yeah, they are very, very difficult to do. And here are some of the reasons that I think they're difficult to use in the classroom. I think they're, yeah, Jessica, organising the use, paying attention to how you're going to frame the probing questions to help with conceptual understanding effectively. Jessica, you could help me write this PowerPoint, because that's exactly right. It's really difficult to know where to start and how to use the manipulatives effectively. It's really difficult to find the time and headspace to make those broader connections with topics. The whole point of using manipulatives is that they're going to support deeper understanding across topics, and that requires extensive planning. And to ensure they have that impact, they need to be used sufficiently consistently, and that requires extensive planning as well. So that takes a huge amount of time. Physically rolling them out into the classroom can be difficult, especially sometimes if you've got you know, if you're moving from classroom to classroom, but also establishing those really positive classroom norms that's going to make their use impactful, so that they're sort of doing the thing that they're meant to be doing with them. And incorporating them into the team's teaching, because if they're going to be really, really impactful, students need to see them consistently, not just in one topic, not just in one term, and not just in one year group. So they're just some reasons that I came up with for why it's difficult, but none of those problems is insurmountable. And it's really important that we keep that in mind, because it's really important that we think about using manipulatives and representations. It's the second recommendation in the EEF report that I just mentioned. It's improving mathematics in key stages 2 and 3. It's number 2 out of 8. And in fact, number 1 is about using formative assessment. And I would say using manipulatives is formative assessment. Thinking about those students factorising 5x plus 15, had they had those multi-link cubes in front of them, those Dean's blocks, we'd have been able to see what they were thinking and how they were thinking about those groupings really, really visually and instantly. And if you also dip into the metacognitive guidance report by the EEF, you'll see that it also mirrors some of the recommendations in there. But coming back to improving maths in key stages 2 and 3, in that second point, to use manipulatives and representations, I think it's really interesting, because although it's gone off the bottom of the screen, they say manipulatives should be temporary. They're not something students use forever. They're just an introduction to start giving them a really concrete understanding of the abstract idea that they're about to develop. They say they should act as a scaffold that can be removed once independence is achieved. So let's just think about that in the context of my example. So we've got our 5A's and our 15. Think about our students not even knowing what factorising is, but having those 5 multi-link cubes in front of them, those 15 Dean's ones, and they're beginning to group them into equal groups just by moving them around. Something that every student could do, and they're thinking about this 5 and this 15 in a concrete way, and beginning to say, oh right, I've got one of my A's in a row, and I've got 3 1s. And that's one of the factors. And they can continue that to get this sense of equality of grouping before they can then perhaps start making a pictorial representation of this idea, and then ultimately moving it on to the abstract algebraic representation. I'm just going to pause there for a moment in case anyone's got any questions about that they'd like to pop into the chat. And the second document I mentioned is this big document by the DFE and NCETM, which is the Key Stage 3 Non-Statutory National Curriculum Guidance. Again, has anyone come across it? Have you dipped into it? Are you basing your resources on it? Please do share in the chat your experience with this document so far. So coming back to that question of why we would use manipulatives or representations. Representations are mentioned 167 times in this document. I did sit and count them. It was published in 2021. And so, you know, it's relatively new, but what's also new is that the word mastery comes up only 6 times, but representations 167 times. I think because representation is probably easier to picture, whereas mastery means so many different things to so many people. But the NCETM do have their 5 big ideas for teaching for mastery. Let's have a quick look at them. They've got representations and structure, mathematical thinking, variation, fluency, and running through all of that is coherence, because there's no point having these 4 ideas in isolation unless they're coherently joined together. So let's just focus in on the representation and structure and think about our example of the representation of that 5x plus 15 with those manipulatives, and how it builds the idea of the structures that we're aiming for in that factorization students. You could equally say we could have also looked at variation, because by varying that question and allowing students to see how the array changes as we vary the expression, would help build their understanding. Chains of reasoning are there for the top right hand corner for mathematical thinking. You know, how does that 3 connect to the 5 and the 15? They're beginning to make those reasoning statements about what they're doing and make connections between arrays and also the algebra. And lastly, of course, fluency in number facts as well, of course, is represented there. So what does it look like at Maths Mastery? So in Maths Mastery, we consider, we have a similar model that's, that represents those 3 disciplinary elements of our subject. So I think as maths teachers are often very, very comfortable in teaching the substantive knowledge of the maths curriculum, very comfortable in teaching angle facts or Pythagoras' theorem, but it's much more challenging to think about the disciplinary knowledge that we need in our subject. How do we think about our subject? And Helen Drury, our founder, in her research for her PhD, found that there were 3 main barriers to students making progress in maths. So the first one being that students had insufficient conceptual understanding. They couldn't see those structures in the maths that they were doing to help make connections across topic areas. They saw maths just as a series of disjointed topics and nothing was connected with anything else. In the bottom right, students didn't have the language skills and communication skills they needed to either communicate their thinking about maths or to even think about it. They may not have had sufficient vocabulary to be able to think about their mathematics. And in the bottom left-hand corner, they didn't have sufficient mathematical thinking skills. So students couldn't conjecture, they couldn't pattern spot, they couldn't think systematically. All the things that we do innately to make us good mathematicians. Those skills were missing from these students that weren't making progress. And they weren't just lower prior retaining students. This was also true for higher prior retaining students. So, you know, those students that come in that are so procedurally fluent from Key Stage 2, really high SAT scores, can do everything really quickly, and then they don't make the progress we'd like to see at Key Stage 3 and Key Stage 4, are missing these skills. And central to everything they do is that mathematical problem solving. By building these 3 areas of disciplinary knowledge, our students become excellent mathematical problem solvers. And what that means, Helen asserted, was that in mathematics, you know you've mastered something when you can apply it to a totally new problem in an unfamiliar situation. So we're going to look at a bit more how we go about achieving that through our curriculum at Maths Mastery. Again, I'm just going to pause for a moment, just in case anyone has any questions. Yeah, red summaries. So going back to that big document from the NCETM. There's not enough time to read it all, absolutely not. And even harder to implement it, to create a curriculum that's got all the really rich ideas that are contained in that document. So we've done a lot of that work for you. Of course, this is what I'm going to share with you. So a huge strand in the document is examining a coherent and connected curriculum. So, of course, that's something we sit and think about on a full-time basis, and we think about how we ensure our students engage with that connected, coherent curriculum. So here's an example of our Year 7 programme of study. And what you can see is that in the autumn term, we start with number. So in autumn 1, it's all number, place value, properties of arithmetic, factors, multiples, because number underpins algebra. So it makes sense to spend a whole half term examining number in depth so that students can go on to algebra successfully. In spring term, we look at shape and space, and they apply all their learning from the number and algebra units in autumn term to the shape and space units, so angle properties, 2D shapes. And then in summer of Year 7 is dedicated to proportional reasoning. And within that bigger connected curriculum, we have connected ideas. So, for example, the array is super important in our curriculum. You've just seen it. You've seen an array in those multi-link cubes. It was a discrete array, but we moved students thinking onto continuous arrays. They've used them in factorization. So in that algebra unit, they had seen them previously in the properties of arithmetic. I'm going to talk a bit more about that later. And they've also used arrays in factors so that they are aware that a factor doesn't exist in isolation. There is a real purpose and rationale. Those grey boxes are from the DFE and NCETM guidance. There's a real purpose and rationale, and we've identified those key mathematical ideas which connect topics together and how they're connected, even more importantly. So let's have a quick look at the suggested sample NCETM curriculum on the top. I've just taken Year 7 rather than the whole of Key Stage 3, and our curriculum at the bottom. I'm just going to let you have a little look and think about what's the same and what's different, but perhaps a more powerful question is why here, why now? I've just alluded to some of our reasoning for why we've put certain topics where we have. That might be an interesting one for you to think through as well. Okay, so what you can see is we've got place value in both of them in the exact same place. And actually, we are a partnership of schools, and we work really, really closely with schools that use the Maths Mastery programme. We had a slightly different unit there, but there was, after COVID, there was a real desire to have a place value unit so we could check that our students coming up have a really, really deep understanding. It is just a brilliant unit. I love it. And some of it's really hard. You wouldn't think you could make place value so challenging, but it's great. Curriculum, and we have axioms and arrays, properties of numbers and factors and multiples as well. I think what's interesting is that we've put prime factor decomposition in the summer term because it underpins that understanding of common denominators. So that's why we've placed it there. And you'll have your own curricula that you will be able to argue why you've placed the things where you've placed them. Arithmetical procedures are in the same place in both curricula and algebra. Spring term, they're a little bit different to each other. We've definitely both got coordinates, perimeter and area. And then transformations are in slightly different places. We put transformations after properties of 2D shapes, seem to make sense, and that comes after coordinates because we continue examining shapes through the coordinate axes so that they build, so that there is retrieval built through every unit that we have. In the summer term, lots of similarities, lots of multiplicative reasoning. You might notice that we actually haven't got any data in year 7. Because actually, to be good to understand data, you need to have really strong proportional reasoning skills. So we think it's worth spending the time in the summer term developing those skills. So by the time they get to year 8, they'll be able to really, really understand data in a much more meaningful way. And then what we have got in the spring term, which the NCETM haven't got, are angles, classifying 2D shapes, and constructions. One of the reasons angles is there is because we use it to build on the algebraic work from year 7. And of course, it underpins the understanding about classifying 2D shapes, which then goes on to areas of 2D shapes, area perimeter. So really strong rationale behind that curriculum to ensure that it is coherent, but also we can make those connections between topics and continue to build on them as we move through every single topic. I wonder how well that reflects your curricula that you've designed or you work with in your schools. It just might be interesting to pop in the chat how similar it is, or if you're looking at it and thinking, wow, that's really, really different to the way we structure our curriculum. Some similarities, yeah, and order. Yeah, because it just makes sense. I wouldn't be surprised. Yeah, Holly's got stats in their summer term, and absolutely there'll be a reason for that. And of course, we can rationalise lots and lots of different orders, and actually that's the most important thing when we're thinking about not only delivering our curriculum, but why it is it. It's not just because this is the next topic or this is the next lesson. To make that curriculum more meaningful requires understanding why each topic is where it is and where it builds upon.
Just have a quick question in the chat.
Is it the case that mastery of one concept will help one to understand the next? 100%. Yes, absolutely. Because it's like we're really examining the structures of the maths as well. Those underpinning structures then transfer. So in fact, I'm going to give you an example now. I hope that it will exemplify it. So I was really lucky because when I was a head of maths, I got to go to Shanghai and see some maths teaching there. And I saw the properties of arithmetic being taught, and more importantly, being used by the students to understand the maths they were learning. So they could talk about the commutativity of addition and multiplication. They could talk about distributivity, and they understood the associative property of multiplication and addition. So they weren't asking those questions that I wonder if you've ever heard them in your classrooms. Miss, am I allowed to do this? Is this allowed in maths? Because they knew why it was allowed. So they knew why 2 + 3 was the same as 3 + 2, to give a really, really simple example. And for that, when I was writing the webinar, I was reflecting on how I had seen it in textbooks prior to that time. So, for example, you know, just a very cursory mention of, 2 × 3 = 3 × 2, but no in-depth understanding of why that was the case. And it just means that those students who are very confident and know that it's the case will carry on and be confident. Those students who are less confident become increasingly less confident because they're never really sure about what they're allowed to do. And then that plays out as they come to unfamiliar problems, because they're not sure what they're actually allowed to do in those unfamiliar problems because they don't have the underpinning knowledge. So one of our first weeks is looking at the properties of arithmetic, and 2 slides that you're looking at here are from our lessons on the distributive property. So this is prior to that lesson on factorisation that I showed at the start. And what you can see is that they're starting off by using multi-link cubes to see how we can split up those arrays into different sections to start to understand the distributive property. And then as they move on, they start seeing it as a more continuous array. And so they're then going to experience those arrays again, as I said, when they're looking at factors. And again, when they're looking at factors, they're thinking about the commutative property. And that's obvious to them because the factors are presented in arrays, and they can see that 2 × 3 is the exact same as 3 × 2 as a factor pair. And then they're going to look at it again. They're going to see them again and get to factorisation. Another example I could have shared was the bar model, because they start off by seeing bar models, they see them as a representation of equality. When in our algebra unit in year 7, students examine equality before they start thinking about algebraic expressions, because we know that students come up from primary school thinking that the equal sign means you do an operation and you get an answer, rather than having a deep understanding of what equality means. And we demonstrate that through bar models. And I was just working with the school last week on a year 8 unit where they're looking at the mean, and they examine the mean through bar models because of that equality of sharing out values, and that representation deepens their understanding of what the mean actually means, rather than it being this sort of abstract calculation, add up all the values and divide by how many there are. It's just a rule that you follow. They've got this pictorial representation. So there was that word again, representations. It's used 167 times in the NCETM guidance report, and you can see it's absolutely embedded through all of our resources in a coherent and connected way. So let's think about some hypothetical scenarios of where you might be with your team. It might be that everyone does their own thing in your department. They're using a textbook. You could have poor teaching, excellent teaching, and it could mainly come from older textbooks. Remember that example I gave you that just had that cursory nod towards the commutative rule. And that content is segmented into isolated chapters, and there's no joined upness across those chapters and topic areas, which leads it to being taught through quite abstract ideas. Or it could be that you've got a sprinkle of representations going on in the department. So I know this was a photo I took in school I visited recently, where again, this was an example actually of a student thinking about equality of expressions, where 2n equals 1m. So how can they justify that mathematical thinking? How can they justify that 4n is equal to 2n? What was so interesting, and I do have the best job in the world, was that I was sitting listening to those students, and the question was on the board: explain how you know that 4n equals 2m. And they couldn't quite do it. They were really hesitant. And then they started drawing their bar model, and their words followed their bar model. So their bar model actually created their thoughts for them. And it was just such an insightful thing to sit and witness in how those students were thinking about their mathematics. We know, I've often seen bar models used in schools that don't use our resources. It's a sort of a go-to for people who aren't particularly confident with representations, and they're often used for ratio and sometimes for equation solving. It could be that you are developing a coherent, connected curriculum, that you are there, you're really getting there, you're really pleased with your curriculum that you've developed, and it's working very well, but actually it takes up all your time and it's really hard to do all the other things that you need to do. So it could be your lead practitioner, your head of maths, your mat lead is working hard to do that, but there's very little time to do the PD on top, and also all the learning walks that you'd want to do to see that consistency embedded across teaching in a department. It's a huge amount to do independently. Or it could be that everyone's singing from the same hymn sheet and it's embedded and consistent, in which case, well done, absolutely amazing, but what next? And I always quote Dylan William when he says, you know, we may be great, but we can all be even better. So how do you move that forward? And more importantly, what do you do? Maths departments are uncertain places. People leave. There is a lot of change. Heads of department move on. How do we maintain that once we've established it? And how do you sustain that consistency that you've worked so hard to develop? So we've shared our curriculum, and I've shared just some ideas of how we embed representations into the curriculum resources. And one of the real joys for me when I do my job is going from classroom to classroom and seeing the same representations being used, because you know that student is going to go from year 7 maths 3 to year 8 maths 3 and have the same experience and build on the knowledge that they learned, because it's not being presented in a completely different way. Let's look at our curriculum program in a little more detail. And I'm going to pause again just in case anybody's got any questions. And I hope that answered Jessica's question about how one concept will help to understand the next. Okay, so we've got quite a complicated little chart here, but I'll try to simplify it for you. So we've got our curriculum overview, that's in the blue box. So this is the long-term elements of our curriculum program. That's all the components of our program. In the yellow boxes, we have our professional development. So we have teaching mastery modules, that's for all the teachers. Program leadership, often the mastery lead is often new to leadership. So we have training to support them in leading the program with their team. And it's just as relevant if you're an experienced leader, because it's looking at how we implement the program successfully. Yes, I will do, yes.
Yes, she will be answering that, how to embed it.
Okay. I can do. I'll finish this slide and I'll come back to it. every element of our curriculum resources. It's in every single slide, but we do have summative assessment as well. In the medium term, we have our units. So again, coming back to the blue, all the core knowledge and skills that the students need to learn for that unit. PD, we have unit guidance. We have notes and guidance embedded throughout the lessons, and we have video overviews as well for teachers to hear from the designers how to implement the programme, to implement how that topic was designed and what the goals and the missions of the topic were. We also highly recommend the team work together to do some co-planning, and we have some models to support the teams with that. And then in terms of assessment, we have a start of unit test and a post-unit assessment as well. That's at unit level. And lastly, at lesson level, for curriculum, we've got the core knowledge and skills for that particular lesson, and then notes and guidance embedded into each lesson slide deck. Classroom resources I'm going to go through in a little bit more detail now, and you can see that green box in lesson formative assessment again, which I'll exemplify in the lesson cycle now. So this is what a lesson cycle looks like for maths mastery. And we have a set of slides. Not every single teacher does every single slide, but we have 4 core slides. The first slide is that we in our lesson slide deck is the do now slide. The do now is retrieval for the upcoming lesson. So it ensures students retrieve knowledge, skills and understanding that's going to support them in their new learning. Sometimes schools edit that so that they've got retrieval from last term, last year, or sometimes they have a numeracy question, but our slide is designed to be retrieval for the upcoming lesson. The talk task is one of my favourite elements of the lesson. You might remember half an hour or so ago, I talked about Helen Drury's research and how students that don't have the necessary language and communication skills often are not successful mathematically. And I would say this is one element of that SMSC question that I was just asked. And I also refer to it as being absolutely essential to that cultural capital that people so often talk about. Where's the cultural capital? I think being able to talk about what you're learning, being able to reason, being coherent and articulate in your discipline is hugely important to students to being successful in life. And that's why I'm so passionate about the talk task, which acts as a hook. And it allows students, this is one of the really powerful formative assessment elements of the lesson, allows students to expose what they already know about a topic to the teacher and give them the confidence to start taking ownership of that new learning instead of it sitting always with the teacher who stands at the front and hands it all over. They're beginning to activate their prior knowledge in preparation for the new learning slide, which formalises many of those ideas that they'll have just met in the talk task, and but which is very much the exposition part of the lesson by the teacher. Once the new learning has taken place, we have a number of quick checks. There are multiple choice questions which allow students to, it allows the teacher to check how the student is following the lesson. I personally think it's a stretch to say how well they're understanding it. Understanding is complex, isn't it? But it certainly allows students to expose if they're following the learning that's going on in the lesson. And where I see these working really, really well, the teachers get out their mini whiteboards and all the students share their answers. I might see an answer build challenge, everyone's answered the question. The teacher asks one student to explain, justify why they've chosen the answer that they have. They then might ask another student to improve on the mathematical language that was used, or maybe to explain why one of the other answers was incorrect. So they're absolutely brilliant for formative assessment in the moment of the lesson, and I love them. Then the developed learning slide is essentially a fluency practice slide. And again, it really is intelligent practice. These are so cleverly designed. And again, another favourite part of my lesson. Some teachers swap them out for the independent workbook. Some teachers just do the independent workbook because there's not enough time to do everything. Some teachers use the developed learning. And then that little green slide that popped up in the bottom is called an explore task. It's separate to the main part of the lesson. It's why it's not in that lesson cycle. And it's a more open investigative task. Some teachers use these with students in a different way to the main lesson when they want to have a more investigative style to their lesson. But they contain the same ideas as the main part of the lesson. There are two plenaries essentially at the end of the lesson. The plenary itself is more of a quality model question where it allows students to expose their understanding of what's taken place over the course. And the exit ticket tests the be able to objective. So it tests, what's the baseline that we wanted students to be able to do by the end of this lesson. And again, when I go into classrooms, I often see teachers using either the plenary or the exit ticket, but very rarely both because time doesn't allow for that. But there is choice. You can choose which one is going to be most impactful for your classroom. So, having seen that lesson cycle, I'm going to bring you back to this component chart of what the whole curriculum programme offers. If we go down to the lesson, you can now match what you've seen about a lesson to that bottom row. You've got your teacher activities in orange, your student activities, and the lesson slides. The lesson guidance I didn't share, but you've got that in-lesson formative assessment as well.
Please quickly see the lesson cycle again.
Absolutely.
And is there a reason behind the answers not being available?
The answers are available in the quick checks. As you click on, this was a change we made at the start of this academic year. As you click through the quick checks, the answer flashes up in the red colour of Maths Mastery. So every quick check has an answer now. In fact, the quick checks are really interesting. The quick checks were a response to COVID and remote teaching. They weren't in the original design of the lesson resources because people were teaching remotely, and we felt it'd be a really powerful way for teachers to ensure that students were following the lessons remotely. And we just got such positive feedback about them that we decided to incorporate them into every lesson. As I said, I just see them being used so amazingly well in lessons, and teachers changing what they're doing on the back of a quick check because if the students aren't following on, they need to do something different. So you get that really responsive teaching that is, just exactly what we'd want to see in a maths classroom. Okay. So lastly, the last slide that I'm going to share is the in-school support model that we offer. We have two packages where you would work with the development lead like myself. The top one is the tailored package, and tailored schools receive 2 school visits, often in autumn and spring, and up to 3 development sessions and 3 training sessions. They can be spread out remotely, they can be incorporated into the visits. And the other package is the leadership package, which has 1 school visit and 2 virtual meeting slots. There are 3 development sessions because one of those development sessions happens within the school visit. We always do a learning walk. This is where I learn so much and where I love going in schools, because we can really talk, after we've been in school, we can really talk in depth about how to move the implementation of the programme forward. It's a very developmental, supportive visit. We look at where the school is at that moment and think about what the next steps would be. And, you know, it's a two-way relationship. It is a partnership. I learn a lot from those visits that I feed back to our design team, and it influences how we continue to develop the programme. And again, coming back to that idea of partnership, so I'm going to stop there, and I'm going to hand over to Sophie.
Perfect. So if you've got any questions now, please feel free to type them into the chat. I don't think we have a function to unmute today, but feel free to type them into the chat. Or if you would like to, if you think of any questions afterwards, please take note of that email address. That is our partnership's email address, so we can answer any questions there. Or we've got that QR code for booking a call in with to talk to me or one of my team.
Oh yeah, going back to the SMSC question, I gave an example of how our development of talk in the lesson allows students to develop in the classroom in terms of developing that cultural capital that they need to be able to go out in the world and articulate themselves, to justify themselves. We often talk about, you know, if we could make the decision between our students being able to tell us that vertically opposite angles were equal, or that they could think systematically, reason and justify, I know which one I would choose for my students, because it's going to give them the skills they need to be successful in the workplace. So I feel that a lot of the elements of SMSC are covered through the very nature of our dimensions of depth and the disciplinary thinking that goes on behind them.